In this video, I'm going to show you how you would split a large algebraic fraction up into some smaller fractions known as partial fractions. This first example has 3 brackets in the denominator. That means that we need to split the fraction up into 3 partial fractions. One of them will have x plus 1 on the bottom, one will have x plus 3, and one will have x minus 1. It doesn't matter what order you put those in. The unknowns at the moment, the numerators at the moment are unknown, so I'm going to call them A, B, and C. It's really important that you write this step down, so you're showing the examiner that you know what your 3 final fractions are going to look like. Next, if we try to make each of those fractions have the same denominator as the original question, that means we need to make sure that all 3 fractions have the same 3 brackets. This first one has got an x plus 1, but it doesn't have an x plus 3 or an x minus 1. So if you imagine writing x plus 3 and x minus 1 on the top and the bottom, that makes the denominator the same as the original one. You could do that with the second and third fractions, making sure that all 3 brackets are visible on the bottom each time. This means then that the A will be multiplied with x plus 3 and x minus 1. The B will be multiplied with x plus 1 and x minus 1. And the C will be multiplied with x plus 1 and x plus 3. On the left-hand side, our numerator was 3x squared plus 18x plus 11. By this point, every single fraction would have the same denominator, so what we could do is get rid of the denominator from every single fraction and just concentrate on the numerators. So this line that I've just written out is crucial. You must write this line, the one without the denominators. That's very important if we want to get marks in the exam. Next, we let x equal a variety of numbers of our choice. You can let x be anything, but there are some clever choices here. For example, if we let x equal to 1, the A and B parts of our question will disappear, because in the bracket with x minus 1, we would have 1 minus 1, which is 0. So I'm going to start off by changing all the x's to 1's. So on the left-hand side, we would have 3 times 1 squared plus 18 times 1 plus 11, which is 32. On the right-hand side, the A part will disappear because the 1 minus 1 bracket is 0. The same for the B part. But for the C part, in one bracket we would have 1 plus 1, which is 2. And in the other bracket we would have 1 plus 3, which is 4. 2 times 4 is 8. So we would have 8 C's, meaning that C is equal to 32 divided by 8, which is 4. Next, I'm going to let x equal minus 3. This is another good choice for x because it makes some of our brackets into zeros. So on the left-hand side, we would have 3 times minus 3 squared, add 18 times minus 3, plus 11, which is minus 16. On the right-hand side, all of the x plus 3 brackets will turn to zeros, so we can just concentrate on the B part. Minus 3 plus 1 would be minus 2, and minus 3 take away 1 would be minus 4, so this is the number of B's, so minus 16 equals 8B, so B is equal to 2. B is equal to minus 2. Finally, I'm going to let x equal minus 1. So on the left-hand side, 3 times minus 1 squared, add 18 times minus 1, plus 11. This is minus 4. And now, any brackets that say x plus 1 will disappear to 0. So the B part and C parts will disappear, allowing us to concentrate on the A part. Minus 1 plus 3 is 2. And minus 1 take away 1 is minus 2. So this is the number of A's. Minus 4 equals minus 4A, so A is equal to 1. So I'm ready to write my final answer. A is 1, so that's 1 over x plus 1. B was minus 2, so that's minus 2 over x plus 3, and c was 4, so that's 4 over x minus 1, and this is my final answer. In this question, we would need 3 partial fractions. One of them needs to have x plus 1 squared. One of them needs to have x plus 1 without the squared, and one of them needs to have x minus 2. It doesn't matter what order you put those in. The numerators are unknown, so we'll call them a, b, and c for now. If you now imagine trying to turn each of these fractions into ones with the same denominator as the question, the first fraction, a over x plus 1 squared, doesn't have an x minus 2 bracket. So I'm going to write that on the top and the bottom. If you want to just do that in your head, that's fine. The b fraction has an x plus 1, but I need it to have another x plus 1, and I also need it to have an x minus 2. And then the c fraction has the x minus 2, but what it doesn't have is the x plus 1 squared. So I'm introducing some things on the top and the bottom just to make sure that all 3 fractions have that same common denominator. By having the same common denominator, we can get rid of all the denominators and just focus on the numerators. So on the left-hand side, we had 3x squared minus 3x plus 3, and on the right-hand side, we have a multiplied with x minus 2 plus b multiplied with x plus 1 and x minus 2, and then c is multiplied with x plus 1 squared. Now I pick some numbers to substitute as x. I'm going to start with 2. So on the left hand side, 3 times 2 squared minus 3 times 2 plus 3, that gives 9. And on the right hand side, anywhere where we see the x minus 2 bracket, that will become 0. 2 minus 2 is 0. So the a and b parts will both disappear, and we can focus just on the c's. 2 plus 1 is 3. 3 squared is 9. We have 9 c's, so c is equal to 1. Next, I'm going to let x equal minus 1. So on the left, we'll have 3 times minus 1 squared minus 3 times minus 1 plus 3. This is 9. And now anywhere where we see the x plus 1 bracket, that will disappear into 0. So the b and c parts will disappear, and we can just focus on the a part. Minus 1 take away 2 is minus 3. So we have minus 3a's. So a is equal to 9 divided by minus 3, which is minus 3. Now, I have used the 2 and the minus 1, which were the obvious choices for x. I've run out of obvious choices. There are a variety of different ways of getting this third letter, but often students like to let x equal 0. 0 is quite a nice, easy number to substitute in. So on the left-hand side, if we put all the x's as zeros, we get 3. And on the right-hand side, if we put the x's as zeros, we would have minus 2a. Then we would have 1 times minus 2, that's minus 2b, and 1 squared is 1c. Then we can put in the things that we know already. Because we know that a is minus 3, minus 2 times minus 3 is 6, and we also know that c is 1. So 3 is equal to 7 minus 2b, so 2b equals 4, so b is equal to 2. So we're ready to now write our final answer. A was minus 3, so that's minus 3 over x plus 1 squared. B is 2, so that's 2 over x plus 1. And C was 1, so that's 1 over x minus 2. And this is the final answer.